What if I told you the next global superpower showdown isn't happening on battlefields or in boardrooms, but in batteries? The race is on. China currently controls over 80% of the world's lithium battery supply chain, but a new contender has entered the arena that could change everything. Sodium-ion batteries, cheaper, more abundant, and potentially America's secret weapon to reclaim tech dominance. Is this the technology that finally lets the USA beat China at their own game? Or is it too little, too late? The stakes couldn't be higher and the clock is ticking as both nations pour billions into securing their energy futures. Let's rewind a bit. For decades, lithium-ion batteries have powered our technological revolution. Your phone, laptop, electric car, they all depend on lithium. And China saw this coming from miles away. While America was busy elsewhere, China quietly secured lithium mining operations across Africa and South America. They built massive production facilities. They trained thousands of engineers. They established the world's most comprehensive battery supply chain, from raw materials to finished products. Remember when we thought outsourcing all our manufacturing was a brilliant idea? Yeah, about that. The consequences of those decisions are now coming home to roost in a way that affects our national security, economic prosperity, and technological independence. The numbers are staggering. China produces 75% of all lithium-ion batteries globally. They control roughly 60% of the world's lithium processing capacity. And they own or have stakes in 41% of the planet's lithium mines. They've invested over $60 billion in their battery industry since 2015, and they're not slowing down. Meanwhile, the US has been playing catch-up, with domestic production accounting for less than 10% of global output. But here's where things get interesting. Lithium isn't the only element that can power a battery, and its limitations are becoming increasingly apparent. Lithium is expensive. Prices have increased nearly 500% in the last 5 years. It's geographically concentrated in just a few regions, many politically unstable. Mining it creates severe environmental damage, requiring approximately 2 million gallons of water to extract just 1 ton of lithium. And perhaps most critically, there simply isn't enough of it to meet our projected needs, with demand expected to increase tenfold by 2030. Ever wondered why your Tesla costs so much? Now you know. You're basically driving around on wheels attached to a really expensive pile of lithium. Enter sodium-ion batteries. And this is where our story really begins. Sodium, the key element in table salt, is literally everywhere. It's the 6th most abundant element in the Earth's crust, roughly 300 times more common than lithium. It can be extracted from seawater, and it's distributed across the globe, with no single nation controlling the majority of deposits. Unlike lithium, which is concentrated in the lithium triangle of South America and in Australia, sodium resources are democratically distributed across continents. Imagine if the next energy revolution came from the same stuff you put on your fries. Talk about a flavor explosion. The geopolitical implications alone are enough to make policy experts salivate. An energy source that can't be weaponized through supply chain control. But here's the catch. Sodium isn't lithium. Its atoms are larger, making it trickier to pack energy densely. For years, scientists struggled to make sodium-ion batteries that could compete with their lithium counterparts. The energy density, how much power you can pack into a given space, lagged significantly behind, making sodium-ion batteries too bulky for consumer electronics and vehicles. Then in July 2021, something happened that sent shockwaves through the tech world. Chinese battery giant CATL announced they had developed sodium-ion batteries ready for mass production, with energy densities approaching lithium-ion levels at 160 watt-hours per kilogram. This wasn't just a laboratory curiosity. This was a commercial product with real-world applications, including integration into electric vehicles. And China was once again leading the charge, with a roadmap to mass production by 2023. Feel that twinge of anxiety? That's what happens when you realize you might be losing a race you didn't even know you were running. American tech dominance, once taken for granted, suddenly seemed precarious in yet another crucial field. But beneath the surface, something was stirring in America. Companies like Natron Energy, Wildcat Discovery Technologies, and university labs across the country had been quietly working on their own sodium-ion solutions. And they had some advantages. America's world-leading materials science expertise with institutions like MIT and Stanford, pushing boundaries in nanomaterials and electrode design. The world's most sophisticated venture capital ecosystem, ready to pour billions into promising technologies. A sudden urgency as national security implications became clear, with the Pentagon identifying battery technology as critical to defense capabilities. And perhaps most importantly, a different approach to the chemistry focusing on hard carbon anodes and Prussian blue analog cathodes that can potentially outperform Chinese alternatives in specific applications. While Chinese companies focused on creating direct lithium-ion replacements, American researchers targeted specific applications where sodium's unique properties shine: grid-scale energy storage, where weight matters less than cost, and longevity matters more than energy density. Backup power systems that need extreme temperature tolerance, with sodium-ion batteries functioning effectively from -20 degrees Celsius to 60 degrees Celsius. Fast charging applications, where sodium-ion excels due to its superior ion mobility, potentially charging to 80% capacity in under 15 minutes. The Department of Energy got involved, launching a $42 million initiative for domestic battery manufacturing under the Bipartisan Infrastructure Law. Private investment followed. By early 2023, domestic sodium-ion battery startups had raised over $300 million, with venture capital firms like Breakthrough Energy Ventures and Kozla Ventures making significant bets on the technology. Here's what most people don't understand about technology races. They're marathons, not sprints. And we're still in the early miles. Yes, China has a head start in sodium-ion production, but the technology itself is just beginning its evolution. Energy density, cycle life, charging speed, all these metrics are improving monthly, not yearly. Current sodium-ion batteries already achieve 85% capacity retention after 4,500 cycles. Far better than most lithium-ion alternatives. Remember when the first smartphones came out? Compare those bricks to what you're probably watching this video on. That's the kind of evolution we're about to see with sodium-ion batteries, with projections suggesting they could reach cost parity with lithium-ion by 2025 while offering superior safety profiles. The most exciting developments aren't happening in giant factories, but in research labs. And there, America still holds crucial advantages. MIT recently developed electrode materials that boost sodium-ion energy density by 40%, approaching 200 watt-hours per kilogram, competitive with many lithium-ion formulations. Northwestern University created a solid electrolyte that allows sodium batteries to work at lower temperatures while eliminating fire risks. Argonne National Laboratory's Artificial Intelligence program is accelerating discovery of new sodium cathode materials, analyzing thousands of potential compounds in days rather than years. This innovation ecosystem, combining academic research, national labs, and private enterprise, remains America's not-so-secret weapon. Domestic sources of raw materials are being developed. Strategic partnerships with allies like Australia and Canada are strengthening supply chains. And crucially, bipartisan political support is creating regulatory certainty for investors, with both parties recognizing the strategic importance of energy storage independence. The sodium-ion revolution isn't just about batteries. It's about energy independence, national security, and reclaiming technological leadership. It's about creating domestic jobs while solving global problems like climate change. And here's the truth that should give us all hope. We're not just catching up. In some key metrics, like fast charging capabilities and extreme temperature performance, American sodium-ion technologies are already surpassing their Chinese counterparts. The race for battery dominance isn't over, it's just beginning. And America has the talent, resources, and increasingly, the will to win. The question isn't whether sodium-ion batteries will transform our energy landscape, they will. The question is, which country will lead that transformation and set the standards for the next energy era? So the next time someone tells you America can't compete in manufacturing anymore, show them this video. Because the comeback story is already being written in laboratories and factories across the country. If you're fascinated by how technology shapes global power dynamics, check out my video on quantum computing, the next Cold War, by clicking the end screen that's appearing right now. Don't forget to subscribe and hit that notification bell to stay updated on the technologies that are reshaping our world. Until next time, keep watching the future unfold.